Hi, in this video we're going to look at hyperbolas. Now, the hyperbola is the graph of an inverse proportion relationship, stuff that you'd have done last year. So with inverse proportion, if you remember back to that work, we had a thing that is called a constant product. So basically any inverse proportion would look something like this. I've got two numbers, let's call them x and y, and they're going to make a constant number. I'm going to, in this case, use the number 12. Now, we rearrange this and we get this equation over here, y is equal to 12 over x. A different example might be to say xy is equal to minus 16. So two numbers that multiply together to give me a constant product of minus 16. And so I could have the relationship or the equation that reads y is going to be minus 16 over x. Now we're going to look at the graphs of these two functions and how they operate. As always, we're going to use the graphics calculator. Now, if we have a look at the graphics calculator, you'll see up at the top over here it says the table function that we're going to use is going to be the function y equals something. So we need to have the equation in this format over here where y is the subject. So I'm just going to enter this in. Y equals 12 divided by x, and execute it over here. And I'm now going to go and look at my table of values. And I've got some strange numbers over there. Let's just go back and change those. So we exit that, go to the set function, F5. I'm going to take my lowest value as being, let's go all the way over to minus 12. Oopsie, we've got double minus 12. And my largest value I'm going to take as 12. And this time I'm going to want the steps to be steps of 1, and X out of there and have a look at the table. And we can see we start to get some strange numbers happening over here. As we go through the list, and there's one noticeable one over here where it says when X is 0, we're going to get an error. We're going to have to talk about that and think about what's happening there. And then as we go through over here, we get these strange numbers happening again. So we'll have a look at these and see what comes up. So to look at what this graph looks like, we're going to use that graphing package that we've used before. I'm just going to move this over here. So we've got that table of values and pull up the graph. There it is over here. And now we just need to go and plot these points. Now, some of these points are rather messy to plot. I'm just going to pick up the points that have integer values. So minus 12 and 1. Okay, so that's a point down over here. When x is minus 12, the y value is minus 1. If we carry on down this list a bit further, we get to when x is minus 6 and y is minus 2. When x is minus 4, y is minus 3. When x, keep going down, when x is minus 3, y is minus 4. We can start to see a shape that's appearing now. When x is minus 2, y is 6. When x is minus 1, y is 12. So we seem to have a curve that's happening over here. But then we've got this situation where x is 0. It says there's an error. I'm going to look at that a little bit later. But let's look at some other points we've got over here when we go and look at the x values when they're positive. So when x is 1, y is 12. When x is 2, y is 6. When x is 3, y is 4. Now this shouldn't be too surprising because 3 times 4 gives me 12. 2 times 6 gives me 12. 1 times 12 gives me 12. Remember we said this is an inverse relationship. A constant product. The constant product in this case is 12, the number that's at the top of the equation. Go down further. When x is 6, y, we didn't get the 4 and 3 one. When x is 6, y is 2, and when x is 12, y is 1. So we've got these nice curves that are appearing, but we need to see what happens as this graph approaches the x-axis and as it approaches the y-axis. So I'm just going to get this out of the way, and I'm going to go back to my equation. Now, to begin with, I'm going to see what happens as the x values get very big. So in other words, when x goes out this way to the right or goes out this way to the left. So when this number down here at the bottom, when the x part, when this part over here gets bigger, the fraction itself is going to get smaller. And as the fraction gets smaller, so we're going to get closer and closer to 1. So in other words, we could have y is equal to 12 over 24. That's equal to a half. Or we could have y is equal to 12 over 48. That's y is equal to a quarter. I'm deliberately choosing nice numbers to work with here. But as you can see, as the bottom number gets bigger, 12 over 72, that's going to be 1/6. As the bottom number gets bigger, so the fraction, the value of y, gets smaller. No matter how big this bottom number becomes, the fraction is still going to remain. So we're never actually going to reach a value of 0 for the y value. So it would appear that as x gets very big or very small on either side of the axes, as it gets very big or very small, the line approaches the x-axis but never actually crosses it. The same is also going to hold true when we think about what's happening with the y-axis. As we approach the y-axis, x is going to start becoming closer and closer to 0. Now, if we think about what happens in the case when x is equal to 0, we would have this situation here. We'd have y is equal to 12 over 0. Now, 12 over 0 is one of those impossible things. It's undefined mathematically. You can't divide a number by 0. So the graph doesn't exist. At 0, at x is equal to 0. As x approaches 0, as this bottom number over here gets smaller, so maybe you've got something like this, y is equal to 12 divided by a half. Now 12 divided by a half is 24. So the y value gets bigger. As x gets smaller, y gets bigger. As if we said x is equal to a quarter, then I'm going to have 12 divided by a quarter. Dividing by a quarter is the same as multiplying by 4, so it's going to be y is equal to 48. So when x is equal to a quarter, y is equal to 48. So we seem to have a situation that as x approaches 0, the y values get very big. That's if we're on the positive side, if x values are positive. If x values were negative, then y would be getting very small. Or it would be getting very big negatively. In other words, very small. So we have this situation of, as the graph approaches the y-axis, it gets closer and closer to it, but it doesn't cross it. It can't cross it because the graph doesn't exist when x is equal to 0. Now we have a phrase here that we use for this sort of situation. We say that the x and y axes are asymptotes. To the graph. In other words, they're lines towards which the graph will approach, but will never actually cross. So if I put the function in, if I put the graph in, we're going to get this situation over here. And as I scroll out in this graph, you'll see that the line seems to be getting closer and closer to the y and x axis, but it never actually crosses it. I can scroll up here, you can see it's getting closer to it, but it's never crossing it. Go a long way down, it's getting closer to it, but if I zoom in, we'll see that there's still a gap that's happening over there. So this line never crosses the y-axis. Okay, I need to go back to, whoa, where are we? Need to go back to all the start over here. There we are. Oh, I think I'm going the wrong way around, don't I? Here we are. There is our graph as we had it just now. So that's what we get when we have the function xy equals 12. Now, if you remember, I also showed a slightly different equation. Let's see if I can get that one. I had xy is equal to minus 16. Let's see what that looks like. In this situation, I'm not going to plot the graph. I'm just going to type in the equation. So y is equal to minus 16 over x. And we get a graph that's appearing in different quadrants now. We've got points on this line where the x and the y values will multiply together to give you 16. So we've got that value over there, this value over here when x is minus 8, y is 2. When x is minus 2, y is 8. Again, a product this time of minus 16. Down over here, when x is 2, we're going to get that y is equal to minus 8. When x is 8, y is equal to minus 2. When x is 4, y is equal to minus 4. We've got products over there that will make minus 16. So when the hyperbola has a negative attached to it, then the curves are going to occur in these two areas over here. We call this area here the second quadrant, and this one the fourth quadrant, and that's when the hyperbolas are negative. This is the first quadrant, this is the third quadrant, and those are the quadrants that we use when we have a positive hyperbola. So I just made a copy of that diagram, and here we have our two types of hyperbolas. The red hyperbola, this is the hyperbola y was equal to minus 16 over x, and that appears in the second quadrant and the fourth quadrant. And then we have this one over here, the green graph, that is y was equal to 12 over x. So that's what hyperbolas look like. They're these funny graphs that occur in two parts of the axes, and we must remember that important word, an asymptote. That's what the x-axis is and what the y-axis is. They are both asymptotes for this particular type of graph. Well, I hope that helps. Goodbye.